Hi there, I'm Marius and welcome to my talk about FrameOS as part of NimConf 2024. What is FrameOS? Well, it's something I call an operating system for single function smart frames, like this one here. This is a 5.7-inch 7-color e-ink display from Pimoroni, hooked up to a little Raspberry Pi Zero W, and it has only one function. It needs to tell me which windows are open before I leave the house. FrameOS started life as a bunch of simple Python scripts and an interface to control them, which I'll show you later. However, Python is slow and efficiency matters with these kind of embedded systems, so I rewrote it all in Nim. Why Nim? Well, I'll also tell you later. This LCD used to get around 2 FPS with Python, but now it can do at least 10x more. The screen itself is also from Pimoroni. It's the Hyperpixel 2.1-inch round, and it's connected to a little Raspberry Pi Zero W. The function of this one is to be a thermostat in the bathroom. So when I press the connected Zigbee button, I can turn the heating on, and then I can go and take a shower. Or turn it off if I don't really need it anymore. So what is FrameOS? Is it a real operating system? Well, in short, no, or at least not yet. It's an app running on top of the Raspberry Pi operating system, so it's more of a user land with its own apps and scenes, like this one here. This frame shows the latest XKCD comic, but if you look here in the corner, there's something interesting. It's a little QR code. You can think of it essentially as a hamburger button for your phone, and when you open it, it loads a little interface where you can control the frame. For example, here, let's set it to the message board. This frame takes about 40 seconds to render, and so while it does that, I'll show you one last frame. This one here is from WaveShare, not Pimoroni. It's their 13.3-inch 3-color e-ink display. Normally have it showing a slideshow of recent family photos and the family calendar, but right now it's showing just some demo data. And this one is running the actual Raspberry Pi 5. Because it's more of a development board, I wanted something fast. And so I installed the big boy. That's the same system. You can scan the code on the top and you can change the scene. We'll do that later. But for now, let's just walk back. As we can see, this one has updated. So if I wanted to, I could now scan the QR code again and change the message to something else. FrameOS has a pretty unique deployment system, loosely inspired by the ESP Home project. To use it, you need to have a control server running somewhere, even if it's locally on your laptop or a computer like I have here. And so this is the backend. Inside here, I have all the frames running around in my house, including some that you just saw. Inside each frame, you can have a bunch of different scenes, and you can install scenes as you need it. Here we have the scene repository that contains a bunch of stuff that you want. And then inside the scenes themselves, you can open them and you can have a look at how the scene is built. If you want, if this is not powerful enough, you can always go deeper and just edit each of these apps on a scene yourself. And then you can get the Nim code behind everything. It's quite feature complete. You can try to mess it around and you'll get some errors, etc. So it works quite well. Once you make any changes to any of the scenes, you're going to hit the big Save and Redeploy button. And this will compile the entire application, the entire FrameOS, into one large binary, upload it to the frame, compile it, and run it. So everything you see here gets compiled into just a single binary. One restart later, and you will have something completely different running on your screen. Neat, huh? And it's restarting. So let's take a step back and look at the bigger picture for a moment. If you want to use FrameOS, the thing you need is a display of some sorts, hooked up to a Raspberry. You then install FrameOS on it. FrameOS itself has a bunch of different parts. You have all the apps and scenes that you deploy, but also there's an HTTP server running on it. There's this entire event loop, there's a logger, there are a bunch of drivers. All of this is controlled by the backend. And while FrameOS itself is a purely Nim application, the backend at this moment is written in Python. It's a little Flask web app. It talks to your frame over SSH, so the only thing you need is to set it up with a Raspberry Pi operating system and make sure you can reach it over the internet. And then the FrameOS backend will do the rest. The frame send logs back through HTTP. The backend is a visual editor and it contains the scene repository, and it has the function that it can talk to not one but multiple different frames. Demo time. I'm going to show you some of the frames that you saw when I was walking around the house and tell you how they're all built. Let's start with the door frame, the first one. This one has a bunch of scenes on it, so also you can control it as needed. But the main one that's also starting on boot is the Home Assistant dashboard. And this is a pretty simple one. You just render an image every 30 seconds, which you get from this URL. And this is the same thing. Home Assistant exports the screenshot that's used here. All of this gets compiled down into one scene. And you can see here the source for the scene itself. A little event loop. Let's look at a bigger one later. So this is the kitchen calendar. Here I also have a bunch of different scenes, and the one running now is called the demo agenda. This one is a bit larger because it has a bunch of things it does. So first up, it splits the screen into two, and then on one side it renders text, and on the other side it renders an image. Text, image. The image itself is just taken from the FrameOS gallery, which is a free gallery system if you want a few GPT generated images to play around with. You can click edit here. It's a pretty simple app that just downloads a URL. That's it. On the other end, however, we render a background color white, and then we write some text on it. And the text is actually rich text, which is we get from an iCal format, which is downloaded from this URL that you pass in as a state. We'll get to that in a moment. This gets processed into a JSON format, then also merged with another application that gives me home recycling data. These JSON elements are just added together, sent on to an events to agenda application. This does a little bit more work to make it all look nice. And then finally that text is rendered. And so you have this scene like it is here. The XKCD scene that you saw earlier is also pretty simple. Here I have a bit of custom code to get the latest XKCD, and it will output some JSON in this format. So what does it do? It just opens the RSS feed and tries to figure out what is the last image and title there. Pretty simple. We then split the screen in two. There's a 15% option. Let's put it on 85% and 15%. The 15% is the text here, and 85% is the image itself. And yeah, we kind of just render it. This is the bathroom. And here the application is a little bit more complex. I again have a little bit of custom code here that manages the heat timer. But the first thing is that we get sensor data from Home Assistant every second actually. And yeah, we store it in JSON. Then we have a bit of custom code to parse that JSON and do something with the data that's there to calculate the times. Finally, we have an if-else block based on if we are heating or not, which then either shows the fire background or the snow background, and finally renders the clock on it. If we are heating, we will also show how much time we have remaining. Finally, let's build a message board. I'm going to open this other frame that you can see here. I have it on my desk now. You should be able to see a video of it just up here. And on this, I also have a bunch of different scenes. The current one currently showing is called the Cuteness Overload, which just shows an image from the FrameOS gallery. I am going to create a new scene. Let's call it Message Board 2. And here we want to replicate the message board we saw in my kitchen. So the first thing we need is a background image. So render image. And what do we render? These are all the image apps that we have in FrameOS at the moment. I'm just going to take Unsplash because it has a nice selection of all sorts of images. And then next to the image, we also want to render some text. And here's the message. Nature is a fine enough keyword. Let's make the font a bit bigger. Hit save and deploy. And this compiles this entire scene that we just created into a little nim file like this, where it's just running in a loop on every render. This is node 1, this is node 3, this is node 2. And yeah, we're currently compiling it, sending it up to the frame. Once it's done, we will re-render the same existing scene because we didn't really swap to the new one. So this animal should change to something else. Yeah. There we go, a little zebra. And once that's done, we can swap the scene here. So let's already ask it to set to the new scene. The one problem we have, however, is that this text is rather static, and that's where state fields come in. So let's add two new state fields. First one is going to be called background. Let's persist it on disk and make it publicly controllable. And the new one is going to be text. Same settings. Now, if we really want to control it, just drag this and swap this out to the text and this for the background. And there we go. We have built a controllable scene. As you can see, it's just reloading and you can see message written on it. Now if we save and deploy, and when it's done, we'll be able to control it a lot better. I'm going to speed this up. There we go. Currently there is no background and no text, so it shows something random, I believe. Background pasta. So it's again going to take a little bit of time, but once it's done, we should be able to see the rendered image already here, and then it's going to update the frame itself. So FrameOS is written in Nim, mostly. The backend, the interface is written in JavaScript, React, obviously. The backend there is written in Python. It's a pretty simple, just REST API. But the code that's running on the frame itself, that's all written in Nim. And why Nim? Yeah, like I said, I had the Python version of FrameOS working, and it was great, but it wasn't efficient enough because I wanted to use real-time graphics here and there. And I looked around in Python, and the best library for graphics, which included things I cared about, like font rendering and so on, is something called Pixie. And turns out that was written in Nim, and that's how I found Nim in the first place. And the best library for Python would have been Pixie Python. And at that point, like, why bother with Python? And so I went on a few-week adventure and rewrote all of it in Nim. A few other things I really like about Nim is first the C interop. So, because I'm dealing with a bunch of embedded drivers and stuff, it really made a difference that I could just use all the GPIO libraries as they were, and everything's just great. The language itself is really beautiful. It's like a kind of like Python with types, essentially, but better. And it's really a joy to use. And another reason why I chose Nim is because theoretically you can run Nim on embedded systems. And because I want to port this to an ESP32 at some point, this was quite key. The status of FrameOS. It's something that I work on in my free time, so it hasn't really gotten a lot of corporate backing or love or anything like that. It has been 1 year since I started developing it, and yeah, it has reached a point of feature complete for my own home usage. That means for me it's kind of done. However, I have a bunch of plans that I want to add into it and places I want this library to go, so we'll see what happens next. But I'm also very curious to hear if anyone from the community will get involved and will want to also take it into some direction. Finally, future plans. So one of the big things I want to do is to make it a lot easier to share scenes and apps. Right now there is some kind of an existing repository, but it's a little bit hard to add stuff there. I want a nice system where you can kind of log in and just upload your files and anyone else can download them. I want more real-time features. I want to show a video on one of these frames. I also would like to play around with real-time user interfaces, but yeah, I don't really have a need for any of that at the moment, so it's more theoretical. I do want a lot more apps on the platform, like a proper calendar, some Google Photos integration and so on. ESP32 support, as we talked about, and yeah, it's something that just requires quite a lot of polish. Everything works, but you might encounter some glitches here and there. Finally, I want to start publishing hardware guides and tutorials about all these different frames. Like I built this 13-inch one in my kitchen. I had to build and print a case for it myself. I'm going to be publishing all of this and a lot more soon. And yeah, that's essentially it. That was my short demo about FrameOS, the system I built over the last year, written in Nim. Very happy with it so far. Questions?